This is Lesson 5-2A from the Algebra Readiness textbook. Grab your notes packet and a sharpened pencil and begin working on both the study guide problem and the writing the decimals in order from least to greatest. Then come on back to compare your answers to mine. For this first problem, you're asked to find the least common multiple. You learned yesterday that to find the least common multiple, you first do the prime factorization and find using a factor tree. 11 is already prime. The prime factorization of 12 is 2 squared times 3, and then you write your variables next to it. The least common multiple is found by multiplying the largest power of each base. I see I have an 11, and there's no other 11, so use the 11. I have a 2 squared, there is no other 2, so I use 2 squared. I have a 3, there is no other 3. If there was, I would use the bigger power. Then I have a C and a C. They're the same size, so I just use C. I have D squared and D. D to the second power is bigger, so I use D squared. Then I have F and no other variable, so just use the F. Then 11 times 2 squared, which is 44, times 3 gives me 132. C, D to the second, F. Next, you are asked to write the decimals in order from least to greatest. Remember that when you're comparing decimals, you compare the place value of each decimal. For the first one, I look at the 2, the ones place. First, I have a 2, a 0, and this one is 24 and 12. That's all I need in order to write these in order. The first one, from least to greatest, is the decimal, 241 thousandths. The second one is the 2 and 41 hundredths. The third one is 12 and 4 tenths. And the fourth one is 24 and 1/10. Number 2. Again, starting to compare by the whole numbers. This one is 1, this is 13, this is 1, this is 1. 13 is the largest, so I'm going to write a 4. The next thing, when I have the remaining 3 numbers, I'm going to compare the tenths place. This one has a 0, the next one has a 3, and the last number has a 0. So the biggest is 1 and 3/10. Now I have to compare the hundredths place. The first number has a 3 in the hundredths place, and the last number has a 0 in the hundredths place, meaning that is my smallest number. Using that same idea, you would have gotten these answers. Today's learning target is to convert fractions to decimals. The first definition I'd like you to write in your notes is for a terminating decimal. A terminating decimal is when the division of a numerator and a denominator ends with a remainder of 0. It's a decimal that ends. For example, 5/8 is the same as 5 divided by 8. Remember, we learned that the fraction bar means divide. So when you write 5 divided by 8 and do the long division, you see that I end up with 625 thousandths. And it ends. See, there's 40 minus 40 equaled 0. It ended. This is a terminating decimal. The ones that go on forever and ever and ever are known as repeating decimals, where you have the same block of digits in a decimal that repeats an infinite number of times. For example, 1/3 means 1 divided by 3. 3 does not go into 1, so I place a decimal and add a 0. 3 goes into 10 3 times, and I get 9. 10 minus 9 is 1, so I add a 0 and I bring it down. 3 goes into 10 3 times, and I get a 9. I subtract. Now, at this point, you see that the 3 is repeating. With a repeating decimal, you write a bar above the digits that repeat, and only the digits that repeat. So you would write 3/10 with a bar over the 3 to indicate that those numbers repeat. So, changing fractions to decimals. Simply divide the numerator by the denominator. Numerator divided by denominator. Let's try it. 1/4. 1 divided by 4. 4 does not go into 1. I add a 0, and I place the decimal straight up. 4 does go into 10 2 times. I add a 0. 4 goes into 20 5 times. This one ends. It equals 25 hundredths, and it is terminating because it ends. The next one, 3 3/10. You do not have to worry about the whole number, only the decimal portion, and then we'll tack it on after the decimal right here. So 3/10 is 3 divided by 10. Notice that the top number is the number that I put under the division bracket. Some of you might have also seen, or you will do this math, and you will see that it ends up equaling 3/10. But do you also see that this is red? This fraction is red 3/10. Isn't this decimal also red 3/10? They are written and said, they're written differently, but said the same way. These are equivalent. So if you don't need to do your work with ones that have a 10, a 100, or a 1,000 in the denominator, that's okay. You don't have to write it. Another thing I want to tell you about with that same idea, looking back to 1/4, or let's go to 3/5. Can I make 3/5 a number that has a denominator of 10, 100, or 1,000? Sure. Let's create an equivalent fraction with a denominator of 10 by multiplying the numerator and the denominator by 2. 6/10 is the same as the decimal 6/10. That's a lot faster than doing the division, isn't it? But keep in mind, you still could do the division. 3 divided by 5. 5 doesn't go into 3. It does go into 30, though. And this decimal is a terminating decimal. This one is also, isn't it? The next one, 1 7/8. 1 7/8 doesn't work as nicely because there is no way to create an equivalent fraction with a 10, a 100, or a 1,000. Well, with a 1,000 you could. And so it's actually faster for me to take 7 divided by 8. 8 goes into 7, it doesn't. 8 goes into 70 6 times. Oh, what am I saying? Eight times. 64. Add a 0. 8 goes into 60 7 times. and 8 goes into 40 5 times. So this equals 1 and 875 thousandths. This is also terminating. There is one more strategy for creating equivalent fractions I want to mention. In 6th grade, you had memorized what each of these fractions, what the base fractions were. You had memorized that 1/4 equals 0.25. So that means if you know what 1/4 is, you know that 2/4 is really 0.25 doubled, so 0.50 or 0.5. And 3/4 is 25 hundredths times 3, or 0.75. The same thing is true about 1/5. And I know that you learned that 1/5 is 2/10. So that means that 2/5 is 4/10, and 3/5 is 6/10, because you just multiplied 2/10 times 3. And 4/5 is the same as 4 times 2, which is 8/10. If you are somebody who has those memorized and wants to use those, you absolutely can. Let's see, another common factor you probably have memorized is 1/8, is 0.125. So I could have taken that and multiplied it by 7 and gotten 0.875. Make sure that you're using all of the different strategies that you've acquired so far in your math classes. Try these 3. Come on back to compare your answers to mine. For this one, I find it easiest, instead of taking 17 divided by 20, to create an equivalent fraction with a denominator of 100, and then taking 17 times 5. 5 times 10 is 50. 5 times 7 is 35. When I add that together, I get 85 over 100, or 0.85. 13 25ths. I could take 13 divided by 25 and do the long division, or I could create an equivalent fraction with a base of 100, and then take 13 times 4. 4 times 10 is 40. 4 times 3 is 12, so I get 52 over 100, which is the same as 52 hundredths as a decimal. 7/8 we actually did on the last page, didn't we? Right here, 0.875. All right, change each of these. Oh, wait, and notice that each of these were terminating decimals because they end. All 3 of them. Now, what about these? Change each of these fractions to a decimal. 2/3. You take the numerator and divide it by the denominator. Make sure that the top number is under the division bar. 3 does not go into 2, but 3 does go into 20, 6 times. Then I subtract. And right here is where you're probably realizing that this is going to repeat. This is a repeating decimal, and the block of digits that repeat is the 6/10. So I put a line over the 6. Make sure you don't do this. That's wrong. Only put a line over the repeating digits. 15/11. Some of you might try to convert that into a mixed number, but others will just put 15 in the division bar and 11 as my divisor. 11 goes into 15 one time, and I get a 4. It hasn't come out even, so I need to add a 0 and a decimal point. 11 goes into 40 3 times, and when I subtract, I get 7. 11 goes into 70 6 times, and then I get a 4, and that's when I realize that I have a repeating pattern. The 3 and the 6 will repeat. So I would say this is a repeating decimal, and the block of digits repeating, I put a line over, which are 3 and 6. All right, the last part. Write each fraction as a decimal. State whether the decimal is terminating or repeating. If the decimal repeats, state the block of digits that repeat. Pause the video and come on back to compare your answers to mine. All right, the first one. You should have ended up with 7/10 repeating. It's repeating. State the block that repeats. I'm just going to put a bar over the block that repeats because that's proper math notation. The next one, 21/22. You should have gotten, you might have thought, oh, it's not ever going to repeat, but the 5 and the 4 repeat. So only put a line over the 5 and the 4, please. The next one, 11/8 would be 11 divided by 8, and you get 1.375. This one is a terminating decimal because it ends. And then 8/11. And it's the 72 that repeat, and so repeat. There we go. All right, let's give the homework a try, which is page 234, 7 through 15. I think it's only like 8 problems or so.